Alright, so in this video we go over section 10.4, Nonlinear Systems of Inequalities. So in this video, first we are going to review linear inequalities and systems of linear inequalities before going to the nonlinear inequalities and then the nonlinear systems. Alright, so let's make a distinction between what an equation is and what an inequality is. So as an equation has a solution that is represented by a single order pair, and it's represented by a line. All right, and in the line, all the points that lie in the line are solutions to a given equation, as opposed to an inequality. An inequality, the solution is a region in this case. Okay, let's make a distinction and see what is the difference between the two. For example, so we have the equation y equals 2x minus 5. Let's graph the equation. Well, so in this case, m, which is the slope, is 2 or 2 over 1. This is the rise and this is the run. And the y-intercept is the point 0 comma negative 5. So let's graph the equation. So let's see. Number one, so the y-intercept, we go to the point 0, negative 5. And then from here we rise 2 units and run 1 unit. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, 1, run 1. And so on. And we have this straight line right here. Alright, so all the points that lie here are solutions to the equation. For example, the point 0 comma negative 5, if you plug in 0 to x, 0 times 2, that's 0 minus 5, y equals to 5, so 0, negative 5. The point 1, negative 3, it's another solution to this equation. So plug in x equals 1, 1 times 2 equals to 3, 3 minus 5, negative 3. The point, for example, 3 comma 1. If you plug in 3 times 2, that's 6 minus 5 equals to 1. So all these points that lie on the line are solutions to the equation. Now, what is this going to represent in this case? Well, for y equals, y greater than or equal to x minus 5. Well, in this case, we're going to have an inequality as opposed to an equation. And in this case, we are going to determine whether these 2 points are solutions to the equation. So what we do is simply plug in x equals to 3, y equals to 1. So is 1 greater than or equal to 2 times 3 times negative 5? Well, 1 greater than or equal to 2 times 3, that's 6 minus 5. And that's 1 greater than or equal to 1. So in this case, 1 is greater than or equal to 1, so the inequality is met in this case. Alright, so it's the point right here. Now what about the point 5 comma 0? Is the point 5 comma 0 a solution? Well, x equals to 5, y equals to 0. So is 0 greater than or equal to 2 times 5 minus 5? Is 0 greater than or equal to 10 minus 5? Well, in this case, 0 greater than or equal, what is this? That's a 5. So this is not true. 0 is not greater than 5. Alright, so that is not going to be a solution to this inequality. That's not going to be the case. In fact, it would be a solution to the inequality to the inequality, but with the inequality sign in the opposite sense, in the opposite way, because 0 it would be less than 5. Alright, so but how are we going to represent these solutions? Well, as you could see from the previous picture, so essentially this line, it's going to divide the Cartesian plane into 2 regions. One region above the line and another region below the line. This inequality y greater than or equal to x minus 5 will represent all the points that are above. And if the inequality sign would be the reverse way, then it would represent all the points below the line. All right, so that's the idea here, how that that line divides the region into two, and the solution to an inequality will be only one of those two regions. Now, to solve inequality as well, we have here a series of guidelines, a sequence of guidelines to use to graph these inequalities. Well, so number one, the linear inequality has to be written in slope-intercept form. That is, we need to make sure it looks like y equals mx plus b. Well, since it's an inequality, this equal is being replaced by greater than, less than, greater than or equal, less than or equal, depending on the inequality symbol that we're looking for. Alright, so if the inequality is less than or greater than, then the line itself is not going to be included in the solution set. And in fact, when we graph it, we are going to graph it using a dashed line, not a solid line. So if the inequality, the line is dashed. Otherwise, if the inequality has the inequality symbols greater than or equal, less than or equal, then the line is going to be solid, just like the one we did in the previous example. All right. So, and then in the end, we are going to select a point and check if it is a solution to the inequality. If not, we shade on the other side of the inequality, on the other region where it belongs. The alternative method, well, so I like using this method better to get the solution set. So when the inequalities of the form less than or equal or less than, shade below. If it's greater than or equal or greater than, shade above. And then in this case, we are going to have actually vertical lines. Remember, x equals to a number, x equals to a number. Well, those are vertical lines. And then if the vertical line, like x less than or equal a number, or x less than a number, look at the direction of the inequality sign, shade to the left. Otherwise, if we have a vertical line with greater than or equal or greater than, we shade to the right. It's indicated by the inequality sign, the inequality symbol. Let's do one example to see how is this going to work. Well, I'm gonna do this alternate method. I think it's shorter to do it this way. So, for example, let's graph the following inequalities. In other words, the first thing we do by putting the inequality in slope-intercept, in other words, it's to solve for y. So if your inequality is not solved for y, then we need to do that. So let me add for x to both sides of the inequality, 3y equal less than or equal for x, and then divide both sides by 3. Y is less than or equal to 4/3 x, and if you will, plus 0, right? You don't have to write that 0, but it's a good for reference. So in this case, let's graph. So the y-intercept is 0, and the slope, which is 4/3, we rise 4 units, we run 3 units, rise 4, run 3, and then draw the line. And in this case, this is going to be a solid line because the inequality symbol is less than or equal. If it didn't have the equal, it would be a dashed line. So let's do it this way and do it the other way around. Now, this inequality symbol means less than. That means shade below. If the inequality had the other sign, the greater than or equal, we would have shaded above. But in this case, we need to shade below. Right? So let's shade below for this inequality. So when you do this in MyMathLab, you are gonna have this graphing, the graphing utility with a bucket of paint, and then you would choose to paint on one side or the other. So in this case, we shade the one below. Let's do another example. So x minus 3y equals to negative 3. Again, this inequality is not solved for y. Let's subtract x from both sides to get negative 3y less than negative 3, less than actually negative x minus 3. And then we need to divide both sides by negative 3. But keep in mind that when we divide both sides of an inequality by a negative number, the inequality symbol reverses. So y greater than x over 3, negative over negative, that's positive 1. And you might want to rewrite this so it's easier to read. That's 1/3 x plus 1. So m equals 1/3, and the y-intercept is 1. So I'm going to go to 1 here, and then from here I'm going to rise 1 unit, run 3 units. Rise 1, run 3. Rise 1, run 3. So, but in this case, so I'm gonna draw a line that connects those 2 points. Okay, so that's the line I'm graphing. Let me box it. Let me actually use a different color. Why not? Okay, so that's the line we're graphing. But in this case, because of the inequality symbol, it's only greater than. It's only greater than. So that's going to be dashed line. See, it's not a solid line like I did on the previous example. It's a dashed line. All right, from here, well, we are going to decide what part of the line. So this dashed line is going to divide the Cartesian plane into regions, the above region and the below region. So in this case, because of the inequality symbol is greater than, greater is above and less than is below. So we're gonna go above. So let's shade above. All right, that's what we're going to shade. Let's do another one. X less than 3. So in this case, we have the vertical line. Vertical line. X equals to 3. But in this case, because of the inequality symbol, this is dashed. All right, so it's going to be a vertical line at x equals to 3. All right, and it's dashed. And because of the inequality symbol, look at inequality symbol. Think of it as an arrow to the right. I mean, actually to the left. All right. And shade everything. Shade to the left. All right. Let's keep going. Y less than 3. Less than or equal 3. In this case, what do we have? Horizontal line. At y equals to 3. And in this case, it's solid because it has the equal part. If it didn't have the equal like this, it would be like the previous one, it would be dashed. But in this case, it's solid at y equals to 3. All right. And less than, so this solid line is going to divide the Cartesian plane into regions, the region above and the region below. Less than would be below. If it were greater than, it would have been above. So in this case, it's below. So shade everything below. All right. So that's how we shade. So let's see. Well, actually, let's try and better shade this. All right. Now, up to this point, we have learned how to graph solutions to inequalities and to linear inequalities. So we shade one side or the other. Now we're going to look at systems of linear inequalities, and in these systems we are going to graph both lines in the same Cartesian plane, but in this case we're going to look for the overlap of the shadings. So let's do a couple of examples to show you how to graph this. Well, the first one is, I guess, really short to do because, well, number one, for this first example, we already have both inequalities in the y mx plus b form. In other words, we have them solved for y. So for 1, m equals to -3 over 1 and b equals to 4. And for the second inequality, m equals 2 or 2 over 1 and b equals to -2. And in this case, look at inequality signs. They are both solid lines because they have the equal part in the symbol. So let me graph the first one. So I'm going to go up to 4 and then I'm going to go -3. So I'm going to run 3 units or go 3 units down. 1, 2, 3 and run 1. 3 and run 1. 3 and run 1. All right, and so that's going to be the solid line. All right. And then for the other line, I'm going to go to the y-intercept at -2. And then from there, I'm going to go 2 units up and 1 to the right. In other words, rise 2 units, run 1 unit. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And let's connect the dots here. Alright, well, I'm not going to do the shading here yet. First, I'm going to do some scratch work. I'm going to do some scratch work here. And in this case, what I will do, okay, let me do another Cartesian plane. And well, I basically have this 1, 2, 3, 4, 1, 2, 3, 4. I have this this line over here and that other line over there. All right, I mean, it's not perfect. I mean, it just looks similar. Okay, so this is 1 and this is line 2. Okay, let's label them and let's interpret. Okay, so in this case, y greater than -3x plus 4, the greater than means that we need to shade above. All right, and I'm going to use blue to shade the first line. Okay, so above line number 1. So if we look at the first line separately, at the diagonal line that goes down, number 1, it divides the Cartesian plane into one region and then the other region here. So I'm going to shade above because it says greater than or equal. Otherwise, if it had the inequality sign reversed, I would have shaded below. And then I'm going to look at the other line. I'm going to look at the other line. In this case, y greater than or equal to x minus 2. That's this line. This line right here divides the Cartesian plane into one region, another region. Because it has greater than or equal, I'm going to shade above, not below. And I'm going to use the other color. And the reason why I'm using these two colors is because so I'm combining pink and blue, we are going to look for the overlap of the color. So in this case, the overlap between blue and pink is purple. In the end, I will only look at the purple shading, and that's where I will shade here. All right. So when you do this in my MATLAB, how are you going to do this in my MATLAB? Well, number one, the first thing you are going to do is graph the lines. And then when you graph the two lines, you're going to have 1, 2, 3, 4 possible regions to shade. In this case, one of those 4 regions will be the overlap of these two lines right here. All right. So in the end, you're not going to do this in my MATLAB. You do this in Scratch first, and then you will look for the overlap, and that's what you are going to shade in. All right, let's do another example. Letter B. So for letter B, observe that that the equations are not solved for y. So the inequality. So 2x minus y less than or equal to 5. So I'm going to move the 2x to the right hand side, less than or equal negative 2x plus 5, and then divide by negative 1, negative 1, negative 1. So y 2x minus 5. But when we divide an inequality by a negative number, or we multiply by a negative number, remember the inequality symbol reverses. All right. Let me do the same to the other one. So let's see. So x plus 3y greater than 6. And I'm going to move the x to the right hand side. 3y greater than negative x plus 6. And then divide both sides by 3. So y greater than 1/3. Actually negative 1/3 x. And 6 divided by 3, that's a plus 2. All right, and in this case, I didn't reverse the inequality sign because we didn't divide by a negative number. All right, so let's graph this line. So this line has an m, or a slope of m equals to 2 or 2 over 1, and a b of negative 5. I'm going to go down to negative 5. And then from here, I'm going to rise 2 units, run 1 unit. Rise 2, run 1. Rise 2, run 1. So rise 2, run 1. 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 And in this case, is it going to be a solid or dashed? If you say it's solid, well, you are right. And the reason is because we have the equal. So let's draw a solid line. And then let's do the next one. In this case, n, the slope, equals to negative 1/3, and the y-intercept equals to 2. So in this case, we go down because it's negative. The rise is going to be negative, and the run will be positive. So I'm going to go to b, which is 2. And then from here, I'm going to go 1 unit down, run 3 units. 1 down, run 3 units. And the same. But in this case, I almost messed this up. So in this case, it's going to be a dashed line. Do you see why is this going to be a dashed line? Yes, because that's this one has it has only the greater than, not greater than or equal. Okay, so when we draw these two lines, we are going to have 1, 2, 3, 4 regions to choose from and find the intercept. So in this case, well, let me do some scratch again, just the same way I did it before. Number 1, well, that's going to look like this. All right. And the other one is going to look solid like that. All right. So, okay. So I'm going to use pink. Well, first I'm going to use blue for the first line. Okay. I'm gonna shade that with blue. And in this case, well, the solid one, the solid line is going to divide into 1, 2 regions to shade. Because in this case we have greater than or equal. Greater than or equal is going to be the above one, not the below one. So let's shade. Alright, so let's shade this one over here. And the dashed line, that's going to be shaded with pink. But in this case, it's also greater than, in this case. So in this case, greater than means above. So this dashed line right here splits the Cartesian plane into the below part and the above part. Because this is greater than or equal, I'm going to shade above. All right, and that's so in this case, where is the overlap? The overlap is going to be right here in this region. So let's go ahead and shade. Let's shade with purple. All right. Okay. The overlap again. The overlap of these two. Again, the combination between blue and pink is purple. We're looking for the purple region in this case. All right. Let's do another one. Okay. Letter C is kind of interesting. Well, letter C. It's a horizontal line. And it's actually solid. And this is a vertical line. And this is actually dashed. All right, it's dashed. So horizontal line at y equals to 2. So y equals to 2. And x equals to -1. So it's kind of hard to see. That's 0, -1. All right, so I'm gonna do again some scratch, because here again when we grab these two lines we're gonna have 1, 2, 3, or 4 regions to choose from. And this is the Cartesian plane. Let me use a different color actually. So at y equals to 2, that's the solid line, and x equals to -1. All right, so in this case, we want for the horizontal line less than, so the horizontal line divides the Cartesian plane into the below part and the above part. Less than means below. So I'm going to shade that using blue with below here. All right, so I'm going to shade below. And then x greater than -1, that's to the right. Because, well, this dashed line will divide the Cartesian plane into 2 regions. Number 1, the one to the right and the one to the left. And numbers that are greater than -1, of course, they are to the right, not to the left. So if we graph, and in this case, look at what we obtain. So the overlap of the regions, the overlap is going to occur here. Do you see where it's occurring? Yes. So let's go ahead and do that. Let's paint first with pink. And then let's paint with blue. All right, so that's our solution, this region, the one that combines the blue with the pink, the overlaps. All right, let's see what's next. So now let's move on to the nonlinear inequalities, right? So now we're going to look at those inequalities involving the conic sections that we have discussed earlier in this chapter. So in this case, what do we have? Y greater than or equal x squared minus 3. All right, so in this case, what do we have? We have a parabola with vertex at a point 0, comma, negative 3. You know, this is 0, negative 3, or it's actually shifted 3 units down. So I'm going to go down 3 units. That's where the vertex is. And well, in this case, this parabola opens up because the square term is x, and it's also positive. So it's going to open, that's 1 here. And then that's the other one here. And now, when we draw this parabola, well, this parabola will divide the Cartesian plane into 2 regions. The one above the parabola, or inside, and the one below the parabola, which is outside. So, greater than or equal means inside or above the parabola. Okay, greater than or equal, actually. And if we had it otherwise, less than or equal, that would be outside, below the parabola. All right. So this is inside, above, and everything outside here, it's outside, below. Either way, you can go with inside or above, or outside, below. Either way, it's whichever you feel more comfortable with. Well, in this case, what do we have? Greater than or equal? Greater than or equal would be inside. So let's shade inside. All right, let's shade inside. So when you draw the parabola in MyMATLAB, you are going to have 2 regions to choose from, one inside or above, or one outside, that's below. Let's do another one. So x squared plus y squared equals to 25. Well, in this case, that's the equation of a circle of radius, 5, center at the origin. And then, well, how to graph inequalities involving circles? If we have greater than or equal, that's well, first of all, let's draw the graph of the circle. Well, in this case, notice we have a greater than only. We don't have the equal, so that's going to be a dashed. So we're going to go to the center, which is the origin, and then from the center we are going to count 5 units on each side. And then we are going to draw our circle, and it's going to be dashed. Notice I'm not doing a solid circle, it's a dashed circle. All right, so in this case, what are we going to have? Inside the circle and outside. So this whole thing is outside. I mean, just look at the boundary here. It's either inside or outside. So greater than or equal, shade outside. Less than or equal, shade inside. Well, in this case, what do we have? The greater than we shade outside. So let's shade outside of the circle. Not inside, outside. All right. So that's where we shade. All right. Otherwise, we would have shaded inside if we had the inequality sign in the reverse form, you know, like this. Let's do another example. Let's do one that involves an ellipse in this case. So we have this ellipse. How do we know it's an ellipse? Well, because both terms are squared, they have a plus in between, and the denominators are different. So that means, well, it's an ellipse centered at the origin 0, 0 with x-intercepts at x equals plus or minus 5 and y-intercepts y equals plus minus 2. Remember, this is a squared and this is b squared. So the intercepts are the square roots of these two numbers. All right. So in this case, let's draw the parabola. Let's go to the center, which is the origin. For the x-intercepts, I'm gonna go 5 units to the right, 5 units to the left. But for the y-intercepts, I'm gonna go 2 units up and 2 units down. All right, and then I'm gonna draw the ellipse. And by the way, because of less than or equal, this is gonna be solid ellipse. All right, solid ellipse, and like this, like this. Now from here to, okay, less than or equal, shade inside, just like the circle. And greater than or equal, then shade outside. So this is inside, this is outside. All right, well, because in this case we have the less than or equal shade inside. I mean, if we had a less than only, this would have been dashed, but we still shade inside. So let's go ahead and shade inside. All right, inside. So that's how. Let's do another one. Let's do the case in which we are going to have a hyperbola. So we're going to have a hyperbola centered at the origin as well, because I mean there's no shiftings here at all. And well, in this case, it's going to, the branches open to the sides. How do we know that the branches open to the sides? Because it's the variable x that has the positive sign. You know, that's the one that opens to the sign. With x-intercepts, I misspelled this. With x-intercepts, the x-intercepts go, in this case, x equals plus or minus 5. In this case, no y-intercepts. Because if the branches open to the sides, then the branches don't touch the y-axis. Otherwise, if we had this reversed, if in this case the y-squared variable had the positive sign, then there would be no x-intercepts, but it would be the y-intercepts, and in this case 4 and minus 4. So this is what we do. So in this case, centered at the origin, the intercepts are 5 and negative 5. And then this 16, that's going to tell us the height of the hyperbola. In this case, from here, x plus or minus 5, and then from here, x equals y plus or minus 4. So here I'm going to go to plus 4 and minus 4. And in this case, I'm going to have these points right here. And it's kind of like a box to draw the parabola. And you might remember on one of the previous videos we drew the asymptotes of this hyperbola. The asymptotes are gonna look like this. They're dashed. I'm gonna use a different color for the asymptotes because they're really not part of the graph. They're really not part of the shading. All right. And then these asymptotes are gonna be helpful to draw this. These two branches of the hyperbola. All right, now what are we going to have in this case? How are we going to so this is going to be between the branches. And then on the branch, So, less than and less than or equal, shade between the branches. Otherwise, if greater than or equal, shade on the branches. Like in this case, well, we have that situation. We have the situation in which greater than or equal. And by the way, the reason why I did this solid is because it's greater than or equal. So it's a solid hyperbola. So in this case, we are going to shade on the branches. Like over here. And over here. Otherwise, if we had this inequality sign to be less than or equal to 1, we would have shaded inside or between the two branches. Alright, so that's one example of each individually. So now we are going to combine these two. Just the same way we did it with the lines, but now we are going to combine two conic sections or a conic section with a line. Well, that's going to depend. Well, number one. X squared plus y squared less than 25. Well, that's what's this going to be? In this case, well, inside the dashed circle, center at the origin, our radius equals to 5. Sorry about that. Radius equals to 5. All right. And then less than or equal, that means below the line, with m equals 1 and y-intercept of 3. Okay, so in this case, it's actually below the solid line. So below the solid line. Okay, yeah, I think I needed to write this better. All right, so let's write down. Let's draw a solid line with y-intercept at 3 and the slope of 1. But this, by the way, is the same as saying 1 over 1. Rise 1, run 1. Rise 1, run 1. You know, rise 1, run 1. So I'm just going to go like this. And it's solid, right? We said this was solid. All right, what about the circle? Well, the circle is centered at the origin and has a radius of 5. Okay, so I'm going to go 5 units, 5 units, 5 units, and 5 units. But it's not going to be solid. Remember, it's dashed. Dashed because it's only less than, not less than or equal. So I'm going to do a dashed circle. And I'm not going to shade anything here yet. Again, I'm going to do some scratch. Remember what I did, the scratch? And I'm going to do the solid line and the dashed circle again. All right? So, what is this going to be? Blue for the circle. Pink for the line. So inside the circle, inside the dashed circle, so I'm going to shade inside the dashed circle, and below the line. So this line right here has an above region and a below region. So I'm going to shade below. And I'm going to look for the region that shades. So for example, when in my MATLAB, when you're doing the homework, when you do these two, when you draw the line in the circle, you are going to have a potential, how many possible regions to shade. Number 1, this part right here. Number 2, this part right there. Number 3, all this region here. Or number 4, inside the circle below the line. So in this case, is below the line but inside the circle. That's where I'm going to shade. All right. So let me do the pink first. And let me now do the blue to make this purple. All right. So that's how. So when you choose the bucket of paint in my MATLAB, in the graphing utility to shade, you will shade inside this. Let's do another one. So let's see, what do we have? So again, circle of radius 5. Really? And the same inside the dashed circle, whose center is the origin again, and the radius equals to 5. So, and it's dashed, actually. It's dashed. I'm going to go 0, same, 5, negative 5, 5. Solid, dashed again. Whoops. Actually, I messed it up here. It should have gone here. Let me see if I can erase this so it doesn't look messy. Yes, of course. All right, yeah, fixed. And then we're gonna have another circle. In this case, well, look at the inequality sign. It's greater than, so that's gonna be outside the solid circle. Center at the origin as well. Radius equals to 3 because 9, the square root of 9 is 3. That's the radius. So in this case, I'm going to draw a solid circle. Again, center at the origin. I'm going to go inside. I'm going to go like this. I'm going to make it solid. All right. So let me do some scratch first. So the solid circle, the dash circle. So inside the dash circle, so for inside the dash circle with blue, inside, okay, so that's inside the dash circle. And then with pink, it's outside the solid circle. Do you see where the pink is happening? I mean the purple. The purple is going on, and it's kind of hard to see because it looks like the paint went kind of. So that's going to be in this region inside, in between the circles. That's where the overlapping occurs. All right. So let's paint with pink first, and then let's paint with blue to make this look purple. All right, so that's where the overlap occurs, right here. Let's do another example. So in this case, what are we going to have? So number one, this one, okay, another circle, and that's inside the dashed circle of radius, actually center at the origin, and radius equals to 4. Okay, and this one over here, it's gonna be that's gonna be a new one, because in this case we have x greater than or equal y squared, not y greater than or equal x squared. So in this case, it's going to be to the right or inside the parabola that opens to the right with vertex at 0, 0. All right, so let's draw the circle of radius 4 and dashed. So center the origin, go 4 units above, 4 below, 4 to the right, 4 to the left. And let's draw a dashed circle. And then I'm going to draw a parabola that opens to the right like this. All right, and it's solid. All right, and it's solid because it's greater than or equal. Okay, so this one I didn't discuss in the individual examples, but I'm going to show you how to do in the scratch. All right, so let me draw the parabola first. So the parabola, the sideways parabola, is going to have inside or right, and outside or left. All right, because in this case I have this greater than or equal, so the arrow indicates on that side. So, and then let me just do the circle, the dashed circle. So it's going to be inside of the parabola or to the right of the parabola with pink, and in this case also inside of the circle. So inside of the circle, let's use blue here. Can you see where the pink occurs? I mean the purple occurs? Do you see the purple? It's right here in this part. So that means we shade here. And over here, all right? Blue, pink, purple. We're looking for the purple. Again, when you do this in MATLAB, after drawing the dashed circle and the solid parabola, you're gonna have 1, 2, 3, or 4 possible regions to shade. You are gonna choose this one. And let's do, I believe it's, oh, there's a few more. There's a couple more, are they? Yes. So we're gonna have 2 circles. Oh, by the way, didn't I do this one already? Let me double check. Yes, for some reason, I don't know why. Yes, this one it's already repeated. I'm just gonna move to the next page. To the next and last page. So letter D is it's a repeat. So let's do letter E. So in this case, we're gonna have an ellipse inside the solid ellipse, and in this case, that's gonna be between the branches of the hyperbola. How do we know which one is which? Well, we'll discuss. Okay, so this is an ellipse because both variables are square. They have a plus sign in between. The denominators are different. This is a hyperbola because both variables are square, but one of them has a negative sign. So the x-intercepts of the hyperbola, well, in this case, it's going to have x-intercepts because the positive term contains the variable x. All right. So let's draw the hyperbola first, and it's going to be dashed, by the way. It's going to be dashed because it has only less than or equal. So it's going to look like this. One branch over here, the other branch over here. All right, so that's the hyperbola, and then the ellipse. The ellipse has x-intercepts at plus or minus 5 and y-intercepts as plus or minus 2. So the solid ellipse, x equals plus or minus 5 and plus or minus 2 for the y-intercept, and this is solid. All right, so in this case we're going to have many possibilities to shape this part right here, that part right there, this region here, this region in the middle, this region right here, and that region over there. Too many to choose from. Again, we are going to do some scratch work. Let me draw the hyperbola. And let me do the ellipse. All right. So blue is the ellipse. Inside the ellipse, the solid ellipse. Okay. And pink will be the hyperbola, in fact, between the branches of the hyperbola, like this. That's between the branches. And do you see the overlap of the colors? Can you see the overlap of the colors? Yes. It's right here. This little portion, this little region right here. All right, and that's where we will have our all right. One more, the last of them. What are we going to have? Well, in this case, for letter F, both of these are ellipses. Number one, inside, because it's less than or equal, that's inside the ellipse, whose intercepts are x equals plus minus 5 and y equals plus minus 2. And also solid, this is a solid ellipse, and also inside the dashed ellipse with x-intercepts. Be careful with the x-intercepts. Now the x-intercepts are the square roots of its denominator plus or minus 2, and the y-intercepts are plus and minus 5. All right, so let's do one solid ellipse. Of course, the center is the origin for both. Center at the origin, I mean, because we don't see any dashed, any shiftings here, so the centers are at the origin. So I'm gonna go ahead and draw the first ellipse. The solid ellipse starts at the origin. From here, I'm gonna go 5 units to the right, 5 units to the left, 2 units up, 2 units down. I'm gonna draw a solid ellipse. And then from there, for the dashed ellipse, I'm going to start at the origin. I'm going to go x 2 units to the left, 2 units to the right, 5 units up, 5 units down. But this one, again, this one is going to be dash. Okay, it's going to be dashed. All right, so let's do some scratch first. So to determine which is going to be the solution set, it could be all the outside, this part right here, that part right there, this right here, this right there, or the middle part. So we'll see. So like this and like this. So again, color coding. Blue is the horizontal and solid ellipse, and it's inside. And pink is the vertical and dashed ellipse, also inside. All right, do you see where the overlap is occurring? It's pretty much inside right here. All right, so let's see. Let's shade. Again, when you're doing this in MyMathLab, what would you be doing first is draw the two ellipses. Well, be sure, well, depending on the case, but in this particular case, one is dashed, the other one is solid, and then choose the bucket of paint to paint only one of these regions. But again, I always strongly recommend to do some scratch work so you can see the overlaps, all right? And then that's how you get the final answer. And this is a good place to quit. This is the end of this section. I will see you in the next video.